Hi class, this is the video for 2.2. So in 2.2 there's more graphs and displays that we will briefly talk about in class. One is the stem and leaf plot, where each number is separated into a stem and a leaf. So if you can see in this diagram right here, these are the stems and these are the leaves. Right here, the stems start off with our tens digits in this case because that is our highest digit, and over here in the leaf is the ones digit. It is similar to a histogram and it still contains original data values. With this data set, it's hard to see a lot of information with the data set just written out. So on the next slide, we're going to put these into a stem and leaf plot. The lowest data value is 78. So notice 7 is our highest value, so 7 is going to be right here, our 10, and then our ones digit always goes to the right in the leaf part. Over here, our highest value is 159. So in this case, we put 15 to the left in the stem and 9 to the right into the leaf. So list the stems from 7 to 15 to the left in a vertical line. So that's exactly what we're going to do on the next slide. So if you notice, this is the data that was on the previous slide organized in a stem and leaf. This is an unordered set because these numbers are randomly as they appeared in the data. This is an ordered set because they go in numerical order in each stack. So since 8 here does not have a number over here to the right, that means there were nothing in the 80s. Don't mess up and put a 0 there because then you're telling me there is a value of 80 and we don't want that. So when there's no value, we just leave it blank. Same with the 9. And when we're looking at it this way, you can see a whole lot more about our data. You can see that the majority numbers start with 120. And you can see that the majority of cell phone users fall between 110 and 130 text messages. Another graph that you might see is a dot plot. So a dot plot takes each of these data values, puts them on a number line, and this dot represents a data value. If you have more than one data value of each number, you just stack them on top of each other. So if I had a third 36, I would stack it right here on top of 36. So with this same data set, we're going to put them into a dot plot, and here it is. You can see now if the data is right here, there's not a whole lot we can tell by just physically looking at it. So we're going to use this graph to organize our data. So 78 was our lowest value point, so it's right here. It's also easy to see that 78 is an outlier. So the majority of our data is between 110 and 130, lying right here. And that's a lot more that you can see than with the original data plots. A pie chart is another thing that we're going to learn, and it is a circle divided into sectors that represent categories. The area of each sector is proportional to the frequency of each category. Therefore, let's look at this data set, which is the number of motor vehicle occupants killed in crashes in 2005, are shown in the table. Use a pie chart to organize the data. Here we have cars, and 18,440 were killed. Trucks, 13,778 were killed. Motor vehicles, 4,553 were killed, and other 823 were killed. So what we need to do is to first find the relative frequency because we need to know what percentage of cars out of the total will represent in our pie chart. So we take the frequency and divide it by the total to find the relative frequency. So cars being 18,440 is going to give us a relative frequency of 0.49, which is around 50%. It's 49%. So since there are 360 degrees in a circle, we will take 360, multiply it by 0.49, we will get 176 degrees. We will do this for each of our vehicle types. And this percentage that they have, this central angle that we just calculated by 360 times the relative frequency, will give us the degree of that representative in the pie chart. Here is the pie chart for motor vehicle occupants killed in 2005. You will not have to create one of these by hand. We will not use pie charts very often, but what we will do is you need to be able to read pie charts and understand the information on them, and we will use Excel if we create one. The next one is a Pareto chart, which is a vertical bar graph in which the height of each bar represents frequency or relative frequency. The important thing about a Pareto chart is that the bars are positioned in order of decreasing height. So the first bar represents the most information, the second bar, the next, and so on and so forth. So the last bar is the piece of information that is the least. So here's an example. In a recent year, the retail industry lost 41 million in inventory shrinkage. Inventory shrinkage is the loss of inventory through breakage, pilferage, shoplifting, and so on. The The causes of inventory shrinkage are administrative error, 7.8, employees stealing, 15.6, other people stealing, shoplifters, 14.7, and vendor fraud, 2.9. So we're going to use a Pareto chart to organize this. As you can see, I've made a table over here that admin error is 7.8 million, employee theft is 15.6, shoplifting is 14.7, and vendor fraud is 2.9. 15.6 is our most in millions lost to shrinkage. Therefore, it's going to be our first category on our Pareto chart. The next highest is shoplifting at 14.7, and then administrative error at 7.8, and then vendor fraud at 2.9. And that's how we would create this Pareto chart. The next one, which we are going to use a lot, especially in Chapter 9, is paired data sets. In this entry, each one of the data sets corresponds to one entry in the second data set. So for instance, if I wanted to label this x-axis height and the x-axis age and the y-axis height, we would say that this person right here was kind of young and short. This person right here was really young but very tall. And this person right here, the very last data point, was very old but very, very short. So this is a scatter plot, and we are going to create a lot of these. The ordered pairs are graphed in the coordinate plane, and they're used to show a relationship. So as you can see, this relationship, the dots are all going down, so it's a negative relationship, but still a good relationship. So when we look at this data set, there's petal lengths on the bottom and petal widths on the y-axis. So as we organize our data, we can see that each of these data points, so for instance, this data point is 30 in length and somewhere between around 12 in width. And the point of this is that we can look at it and say, okay, there's a positive thing going on here, right? And it looks kind of like a line. So I feel like I can conclude that as the length gets bigger, the width gets bigger. And that is the point of these scatter plots. That interpretation can be made, and that is what we're going to be doing in Chapter 9. This is the last one we're going to talk about today, which is graphing paired data sets. Just like the scatter plots were paired, a time series is also paired data. So here is a table that lists the number of cellular telephone subscribers in millions for the years 1995 through 2005. Construct a time series chart for the number of cellular subscribers. So I'm going to let the horizontal represent the years and the vertical axis represent the number of subscribers in millions. I'm going to plot the paired data and connect them with line segments. This is how you would construct a time series chart. We're not going to construct very many of these, but it's important to know how to read these and to understand this chart. So if you notice right here, each year has a dot that corresponds to both the year and the millions of subscribers in that year. And you can see that this continued to go up from 1995 to 2005. And that is it for Section 2.2.